And yeah, thank you so much for everybody for waking up so early. If you're not morning people like I am, it's even earlier for Chris, our guest speaker, because he's in the UK, so it's 7 there. And I'm just gonna go ahead and start. So thanks again. Um, so welcome to this webinar. This one is about cybersecurity, the immediate and future changes, which is put on by DIH². I'm Alex Carrasco. I'm head of communications at ISDI Accelerator, which is the innovation hub of ISDI. And in this webinar, I'm going to introduce you to the DIH² network and its purpose, and then I'll basically take you through a resource that we're offering currently to you as part of DIH² services. These are free online courses about technological and digital skills, which are designed to be useful for SMEs and individuals that are working more specifically with, the manufacturing and robotics sector, have companies of that kind, etc. And then basically I'll hand it over to Chris. He's our guest expert this time and the creator of our course, Cybersecurity, Immediate and Future Challenges. And he will take you through the key points and about the topic itself. And when he's done, we'll just have a few minutes for questions and answers. So let's get started. DIH, sorry, excuse me, anybody saying something? No, sorry, that was me. So DIH² believes in the power of robotics to transform the agility of manufacturing and SMEs and to drive economic growth across the European Union. So our role is to facilitate the connections that enable agile on production in factories. Speed and versatility are essential to satisfy customer demand. So this is originally funded by Horizon 2020, which is the European Union Research and Innovation Program, tasked with bringing great ideas from lab to market. And we aim to generate innovation that maximizes productivity and optimizes agility in manufacturing SMEs and mid-caps all across the European Union. So in addition, our goals include improving the cost effectiveness of advanced robotic solutions and driving growth on the robotics market. So we already have a large and growing ecosystem of different organizations that have joined our DIH² network. So if you're interested in learning more about joining, you can definitely visit the website, which is DIH² / not / hyphen square.eu. I'll put the link again at some point. So the DIH² network is managed by a number of different partners that come all across from Europe, and each has a very specific and different role that they're playing. But as I said before, ISDI is I am from ISDI, which is a business school for the digital era based in Spain. We have offices Madrid, Barcelona, Paris, Mexico, Silicon Valley, Malaga. I don't know, I might be missing, but basically there. And our role is to provide training courses that are currently open and free for anyone to access, what we call the MOOC courses, massive online open courses, sorry. So the objective of these courses are, as you can see here in this slide, we aim to introduce users in the European manufacturing sector to new technologies and ways of work, to teach how to implement those ways of working, and to ultimately support the update of innovation in manufacturing SMEs across Europe. You can view all our courses in our online platform, which is, you can see the URL down there. It's DIH-square.mooc.ramp.eu, and you can browse the entire catalog without even registering. But if you do actually want to take a course, you'll need to create an account and then access all the didactic material. It's really quick and easy to create an account. Just a screenshot example of the, we have a number of courses that are specifically focused on technology related to manufacturing and robotics, more technological, more technical. And here you can, it's a better overview of what we have on the list, at least at the moment, and we're always, developing new courses and everything. And in addition, we have a range of courses about digital skills, which are aimed to help SMEs, mid-caps, bring your knowledge into the modern world. Topics covered are agile methodology or data-driven marketing, interface design and usability, and many more. And all of our courses will feature video, text, slides, graphics, and some interactive learning experience. So many courses also allow you to test your knowledge at the end of it with a self-assessment. And the length of the time can vary from 1 hour to less, up to 10 hours, more or less. And it depends on the topic. Again, this is the URL that you can use to access the platform. And it's open for everybody. It's not exclusive for anything. So, students, researchers, if you're working in a manufacturing company, if you want your workers to get knowledge about specific topics, this is the place to go. So now, to the interesting part, I'll introduce you to our guest speaker, Chris. He's a Principal Security Advisor for Smart Cities in the UK, Government Security Agencies, the National Centre of Cybersecurity, and the Government Communications Headquarters. So it's pretty impressive. Chris is a global leader in decentralized communication on the cybersecurity space. He's been educating and working with large global corporates and governments to make the world a safer and a smarter place. He focuses on large-scale infrastructure projects, logistics, defense, healthcare, smart cities, and autonomous vehicles. So he's with us today talking about cybersecurity, and we're really glad to have you, Chris. So thank you so much, and take it away. I'll stop presenting my...
Thank you, Alex, for the intro. So as Alex pointed out, it's 1 hour earlier for me. I'm here in Oxford. I'm part of the one part you missed out on the bio, which is a little outdated, is I'm part of the department here at Oxford, Department of Computer Science as well. So after I get to teach you guys, I get to spend all day talking as well. So anyway, yeah, thank you for that, Alex. Really great. Okay, I'm going to quickly share the presentation. So just give me a second here. All right. Can everyone see this?
Yes, you just need to press full screen and perfect.
Okay.
There you go.
Okay. So I always kind of like to start out this these kind of presentations with I just can't go back now. Hang on. Sorry, guys. Just a minute. I don't know what's happening here. Just a minute. Back. Right. Okay. Sorry. Little technical difficulty. I'm trying to get this screen here. I'm not in my office, obviously, so I'm kind of at a hotel. Okay. So I like to start out these presentations kind of like talking about real world things. So I didn't realize until Alex was talking about some of the people that would be joining this, that there's maybe a heavy concentration around robotics and factory and automation and all that, which is great because there's been a lot of work done in that area recently, including some of the work that I'm doing here at Oxford. But anyway, I wanted to start out the presentation and see how well this works, right? Because I've got showing this. Okay, I'm going to go. Oops. Yep. Okay, so I'm going to have to reshare my screen. I wanted to share this with you. So I don't know if any of you have. Can we stop sharing? Can you guys see this this thing that I'm showing here on the screen? This globe.
We're seeing like a globe with lines.
That's it. Okay, fine. Okay, so this is one group that basically shows, these are all live cyber attacks that you're looking at. And there's a couple of companies that show this. Kaspersky is one of them. I like these. This is actually Kaspersky. There's FireEye. There's about 3 or 4 of them. You can just look them up. If you put live cybersecurity threat in your Google search, you'll find companies that do this. So these are really live events. It's showing which countries, what kind of attacks they are, and you can drill down. So right now, the UK is the 29th most attacked country. But the point of the slide, the point of this to show you is that cybersecurity, everything is under threat almost all the time, right? And it's all automated. People are scanning ports, people are sending out injections. So it's really important to understand that cybersecurity is, not a group of concentrated hackers necessarily. It's literally nation states. And if you start looking at these maps, you'll see like, even friendly states like US attacks Spain constantly and vice versa, or France attacks Italy. It's not just the people in the media that the governments think, oh, we're enemies and trying to make it out. It's literally everyone attacking everyone. So and sometimes it's not malicious at all. Sometimes it's to say, hey, your ports are open, or you got these kind of vulnerabilities. But more often than not, it's to inject some type of malicious code or get some information. Okay, so I'm going to stop sharing this and go back to the presentation. So just give me a second. I'm going to go back to the presentation. So I just think it's important to understand that it's literally 24/7. So the world is being attacked all the time. No question. So just give me a second. I'll get back to the presentation. Sorry, guys. Away here. I'm working with one hand tied behind my back. Okay. Sure. There we go. Just give me a second. All right. Can you see that? Yeah.
Yeah.
Okay,
Oh, good.
Good. Okay. So no more going off. So just to, understand a little bit about what's in the courses, right? Understanding cybersecurity. Often when people think of cybersecurity, they think that it's highly complex, which it can be. But I mean, when I teach these classes, I like to keep things quite practical, fairly simple to use. I mean, the one thing about cybersecurity is you can go down a rabbit hole. I mean, there's a lot of different, and maybe you'll get a taste of that from these couple of slides. There's a lot of different branches of research and all sorts of things, right? But anyway, I'd like to kind of keep it a little high level for people in industry, right? Which is good. So, understanding why is it important? Why should you care about it? What are you trying to protect? What are people trying to protect? Who attacks? And then also understanding, I mean, this is less about cyber, the last point, I mean, the fourth point is less about cybersecurity and more just understanding networks. To understand cybersecurity, you have to understand how networks are designed and constructed, because everything's a network, right? And then lastly, I spent a lot of my time thinking about changing or making better the way cybersecurity works now, but also because of some of the future threats which are coming online, which I'll talk to a little bit in this class, right? Okay. So, yeah, a second. Okay, I'll make sure I get all my slides here. Okay, so basically, this is what security is. I mean, what is the concept of security? You have assets. So assets can be data. They can be, well, it's usually some kind of data, but different types of data, right? About activity. It could be, an asset could be data that's generated in real terms. An asset could be a key, a cryptographic key to something else. So anything that's valuable to your ecosystem is an asset, right? And then you've got the security that protects those assets, right? And then you've got threats against your security, whatever your security layer is. And then there's some attacker. And as I just showed you at the beginning, attacker doesn't have to be anyone per se. It's not like, it could be 20 countries at once trying to attack you more, right? And those attacks, if you start delving into those attacks I showed you on the first slide, or the first web page there, you'll see that it's not just industrial facilities that are being attacked. It's people. Sometimes it's often people's home Wi-Fi networks, all sorts, right? So it's literally everything all the time. And I think that's really an important thing to keep in mind, is that it is literally the Wild West, and people are scanning ports 24/7, all countries, all the time. It's really important to understand that, right? So if you superimpose that onto this, right? So, who's the attacker? Well, I mean, what a team of bots in France, that could be an attacker, right? So it's not even like an attacker doesn't even have to have a face, or usually doesn't have a face, right? So it's important to kind of just keep it in mind, right? When you look at the kind of overall structure of how this works. Okay. So here's the good news, right? kind of good news is that all crypto systems, all security systems kind of work the same way, right? So the first layer in a crypto system is called authentication. And I'm sure you guys all have heard of it. And every time you log into your computer, you're authenticating you yourself, your password. Authentication is and there are many forms of authentication, although currently they're kind of a variation of one type, public key infrastructure. But authentication basically is, do you trust the thing or person you are going to communicate with, or do you not? So you authenticate to say, yep, I am that person, and that person or that thing on the other end says, yes, I am this thing, I am this person, authentication. The second stage in a crypto system is called authorization. So once you're authenticated, meaning you are what you say you are, they are what they say they are. The second step is authorization, meaning, okay, now that we trust each other, that you are who you are and I am who I am, right? What can we do, right? That's the authorization. What can we do now that we can talk, right? And then the next layer is encryption. So when we do this, how are we going to keep that private, not confidential? That's a different thing, private from anyone else who's not us, right? And then the last layer is network security. And that has to do with all sorts of frameworks and other ways of getting encrypted data between parties to each other. So that, and I'll show you a little bit about what that network security looks like in terms of structure. I think it's the next slide, actually. Now, so going back to assets. So again, what are you protecting? Where are they? And how, right? So this is a bit of a combination slide. So again, going back to the first slide, assets. So we're talking about assets. So what are you trying to protect in all security, right? You know, content, your identity, your location, data that hasn't been generated yet, cryptographic key. There's a lot of things that you're trying to protect, right? One of the mistakes that I will say that not just individuals make, but also industry makes, right? Is, although industry less so, but is, oh, well, we don't have anything of value, or I don't have anything to hide, so I kind of don't care who gets what. I mean, beyond financial information and things like that, right? So that's a kind of a privacy thing. The one thing you have to understand in security, there's a difference between privacy and confidentiality. So if two parties are communicating, it may be private, but it's not confidential, i.e. it's known that those parties are communicating, right? So you have to kind of separate out privacy from confidentiality. But the point I'm trying to make is that no matter what your data is, it should be, whatever it is, content, identity, anything, right? It should be protected, because what you don't know, or what nobody knows, is how that data will be used in the future or at some point, or what it will be combined with, or so people don't know. I mean, so the best thing is to try and protect all assets all the time. And so where are the assets found? Not surprisingly, you know, on IoT devices, in servers and on your desktop, mobile, all sorts, right? So no surprise here. And, you know, how do all those things, and I'll get to a slide in a minute, how do all those things access networks, right? I mean, get to the outside world, right? So there's many layers. There's obviously the networks themselves, which we talked about, operating systems, and then all the code that has to be built to make those things work, right? So, all right, so this is kind of an industrial, so I'm trying to move my guy out here. This is kind of an industrial thing, but you can put the sensors, you could kind of put, you can, at the very bottom of this diagram, you can kind of also replace sensor with device, but since a lot of you are in industrial, this is kind of more relevant anyway, right? So this is kind of how it all works, right? You've got sensors going up to microcontrollers, hubs, which then goes to a gateway, which goes to an internet, right? So I'm sure you guys have all seen this if you're working in the industry. I mean, this is pretty normal how things work, right? So why it's important to understand this, right, is that systems are attacked based on how they are constructed, right? And in the case of 99.9% of the IT world, it's built very highly centralized, right? And so that's good and that's bad. I mean, it's bad in the sense that once somebody attacks the central system, they have the keys to the whole system or most of the system. The other problem with this model, which is the way, like I said, computing works today is that things at the very edge, sensors themselves, cannot be secured very easily. Some vendors are trying to build in some types of security, but they cannot run traditional cryptographic algorithms that for example, PKI, public key infrastructure, when you log into your computer, right? Sensor cannot do that, does not have the processing power. So that's the other problem. So like I said, the good news is that, it's easy to understand the structure, and all structures are kind of built like that, right? So here is what, oops, sorry guys. So I'm kind of having a hard time looking at my screen here because I got a whole thing across the bottom. Anyway, so all right, so this is important to understand. I'm sure you've probably seen this before. So all networks have an abstract architecture, right? So this is a way of describing about what happens when in a network, right? So I'm sure you probably have all seen the OSI model, which now has been shortened to the TCP/IP model, which is just a way of describing different stages in a network. So everything from physical bit transmission all the way up to the application layer. So application layer, which is what you interact with, right? So, the flow of information goes up one way and comes down the other way. So the TCP/IP model is the one that most people refer to, but it's still interesting to understand where the TCP/IP model came from. So TCP/IP model is just a truncated version of the OSI model. Basically, it's the same thing. It's just, you can see like the transport internet layer basically is, our network access is basically data link and physical all into one. And then the application in TCP/IP is basically session presentation application. Basically the same thing. People just have shortened it to be TCP/IP. But what's interesting here on the right, you can see that at any level in this abstraction, you can attack, right? And so I've listed out some of the attack strategies. So like literally at every point in this model, there is a way to attack this model, not surprisingly, right? And so that, again, that first website I showed you, right? That'll be a combination of attacking the network architecture at multiple levels, right? It's not just, oh, we have to go in at like the physical level or the data, it'll try to go in multiple levels at the same time, right? And launch attacks, right? So now it's actually gotten even worse because of all the AI that's out there. So now the attackers are using AI themselves and neural networks to do smarter attacking, right? So they get all this data in real time, and then they start, going, oh, well, if we do this, the machines are doing it. Nobody's doing it, right? So it's gotten even worse. But anyway, the point of this slide is to show that a network model can be attacked at any level. It's important to understand that, right? So types of networks, right? So most networks that we see today are either centralized or partially centralized, but usually centralized. But the important thing to understand here is, I'm going to see if I can get this out of the way. Sorry. Oh, there we go. Even better. Kind of is this is pretty easy to understand, right? So like most networks have some centralized something, and then they go to, connect out to another centralized thing, so it's usually a combination of the highly centralized plus a star, partial mesh, right? So if you take the first star centralized network and imagine that center point is the center points of all the other ones, that's kind of what networks look like. However, the big issue is that, in 2023, networks look a lot like, or need to look a lot like the first two, and need to be fully decentralized. And so that means that anything should be able to talk to anything else without going through some centralized thing, right? So server or authentication or whatever it is, right? Or authenticator, not authentication, right? So as time kind of moves on, right, and things become vastly more complex, we're seeing a need to move away from highly centralized network models, right? And that has a whole bunch of implications, because as you've just seen in the previous slides, all security has been designed for central networks, right? So when you start having decentralized networks, then there's kind of a big issue, right? The other thing that's interesting here that a lot of people don't talk about when they talk about networks, although starting to, is the concept of motion or moving. So when people think of networks, like in a factory, you think, okay, well, here's a network in a factory, it is what it is, it stays. But the reality is networks themselves are becoming dynamic, meaning, so think about swarms of drones, right, that are networked together. So that's a good one to think about. So think about drones, right? So a bunch of drones, and they're all networked together. But you see, like, not only are they networked together, but they can be networked with other groups. So you've got these moving networks, right, that change over time, right, and need to talk. Other parts need to talk to other parts, and all this. But imagine like a smart city or something where you've got a lot of things coming in and out of different environments. And you can see where having a centralized network is almost an impossibility and a problem. And because that's a problem, the security is a huge issue. So one of the reasons, and I'll get to it in a minute, no, actually I'll save it for the next slide. So the only thing I want to introduce here, besides highly centralized networks, which is mostly what we have to fully decentralized networks, is the concept of motion. So networks can kind of be rated on the scale of completely static, meaning here's our set network, even if it's decentralized, doesn't make any difference. Here's our set network, nothing's going to change in it. I mean, it's always going to be these assets. To highly dynamic networks where things come in and out, things change, positions of things change over time. So, in most industrial settings, you're going to get, some parts of it are going to be highly static and some will be highly dynamic. So vehicles coming in and out of a facility is a highly dynamic situation. So that vehicle is never a permanent part of the static network that's in a factory, for example, right? So things like that. I mean, just think about, add the concept of movement in a network over time to just thinking about networks. I think that's an important thing, especially as we progress forward with smart cities and even factory automation, right? Okay. So why are we here? So this is an interesting thing. I kind of like to put a little history on this. So if you think about the progress of humanity, right, when it comes to these technologies, we started the first industrial revolution at the end of the 18th century, right? So that was, steam power, some mechanization, all that type of thing. So, down to the water mills, the windmills, all sorts, right? So we started, we forget that, we're a couple hundred years in at this point, which is great. So after that, we started adding basic electricity, like at the end of the 19th century, right? So like at the turn of the century, 1900s, we all know, I mean, the country I'm sitting in right now, the UK, was the leader at that time in the second industrial revolution, right? All the factories here in the UK. And then the third industrial revolution is when basic computing and kind of the concept of IT came in. And sadly, we still have echoes of the third industrial revolution now. The fourth industrial revolution, I would say, probably started, around 2018. And we're making a lot of progress, but there's a lot of things. So the fourth industrial revolution, I think somebody teaches an entire class on the fourth industrial revolution, but it's basically the merger of physical systems and cyber completely, right? And adding AI and all sorts, right? So we're, if you take the last two and you understand what I just said in the couple slides before about the whole centralization, and you say, okay, well, we've got this world now where a lot of things need to communicate with a lot of other things intelligently in real time, then you understand very quickly that in this vision of the world that we have coming forward, to have things highly centralized, especially from a security standpoint, is almost impossible. But it's just interesting to understand where we are kind of in our journey as human beings, right, on this thing. So all the things that are enforced, I don't need to go through these things. I'm sure you guys have seen lots of these things, but this is some of the things that comprise the fourth industrial revolution, everything you know that you kind of deal with on a daily basis. So in my company in IOPTIC, we're dealing with a lot of these things, including the military stuff, the IoT stuff, the city stuff, the financial services, automation, all sorts, right? So it's an interesting time. to be doing this kind of work, because there's the whole structure of security needs to kind of change around the new architectures of what's happening. So just to kind of describe what's out there right now when it comes to security, right, is, there's lots of low powered devices. So I'm sure any of you who work in a kind of factory setting will know that it's not just sensors, it's PLCs, which are programmable logic controllers, which are in 90% of all infrastructure in all factories. And to be honest, PLCs are kind of a leftover from the third industrial revolution. They're basically like dumb computers, but they control a lot of things, right? They control sensors and actuators and all sorts of things. But the part of the problem is they're hard to configure. They kind of are meant for purpose to do simple things, but they're everywhere in every country. And, so that's a problem, right? The other kind of issues that are out there that you should know is obviously there's a lack of universality. So, I'm sure many of you have come across the many types of Linux, Unix, or even worse when you're using Windows or other systems like that in your industrial systems, right? But there's a lot of problems between interoperability between systems. And as I've already described, there's a lot of, now in 2023, but in the last 5 or 6 years, there's highly dynamic. I mean, when you think about cybersecurity now, you have to think about dynamic situations, not just a network that sat there, right? So, which is kind of what's been happening over history, but that's not the way networks are going to work now, right? And as I pointed out before, it's currently everything's based on the client server model. That's just another way to say that it's highly centralized, right? The new thing that you've probably heard of is quantum computing. I'll talk a little bit about that. I've got a couple slides on that. I'll talk a little bit about that. AI, which you've all heard of, right? Right now, when it comes to security, like I said, because it's all designed around centralized systems, there's certificate authority or central authority that's usually required for just to start authentication between things. And then those certificates that things have are static, meaning they don't change. So if you know about basic cryptography, a certificate is like a part of a key, and those keys don't change. And so that if they don't change, you can change them, but people don't. It's very time consuming. It's not cost effective, all sorts, right? The point I'm trying to make is that right now in cybersecurity, things are authenticated. So remember, authentication is the first part of a security system: authentication, authorization, encryption, network security. So things right now, most everything is authenticated now just based on the fact that it has a certificate. So the thing right now doesn't have to prove that it's the thing. It just has to prove that it has a certificate. I have this certificate, so I'm okay, right? That'd be like kind of like giving your friend your passport, and as long as they had a passport, doesn't make any difference, they could just use it, right? So maybe not that bad, but close, right? So you can start building up a picture in your mind of like why things are not particularly secured when you've got everything being attacked. You've got highly centralized systems. You've got systems that can't even run security at the edges. In particular, you've got this old-fashioned form of certificate-based security, all sorts, right? So part of these courses is to, for people who are taking them, is to start putting the pieces together and start to kind of go, oh, I mean, one of the things that I like to do is to, kind of paint the picture and let people draw their own dots, and hopefully, maybe one day start contributing to the solutions, right? Because there's plenty of room to contribute to the solution, right? So, so I want to talk a little bit quickly about quantum computing. I don't know how many people have heard of quantum computing. In fact, actually, one of the classes that I'm doing today, there's the quantum class is next door, and in the class that I'm doing, it's got like 15 people, and the quantum class has got 4 people. And we made a joke, and I said, yeah, it's because it's one of the most difficult, concepts and difficult things to understand currently in computer science is the quantum world. So you have to be a little bit of a physicist to understand. But the point is for anyone on this call is quantum computing, once it comes online, and so there's a picture of a current quantum computer there. Quantum computing now is kind of what computing today was in 1950s. I'm sure you guys have all seen those IBM rooms full of, servers and, and it didn't even have, 1/10 the power of this phone, right? So quantum computing is a little bit like that today in the sense that it's whole rooms full of 0 Kelvin electrons, but not all quantum computers look like that. So there's a lot of progress made on putting quantum on chip. So what is it basically? So just quickly, instead of using, it's a whole course on quantum computing, right? So and probably beyond the interest of anyone fully, but do understand this. It basically will make what we're doing today look like stone wheels, right? In the sense of computing power. So I'm not going to read the text there for you, but the one thing to understand is the kind of speeds we're talking about, right? So I put an example by some Swedish researchers. So this was actually a couple of years ago. And so remember when I was talking about certificates on, so you can think about like that as an RSA key, right? So a 248-bit RSA key is vastly complicated. And these computers, I mean, these researchers showed hypothetically that a quantum computer could, so a brute force attack, right? So if you take a string of numbers, and in this case, 240-bit RSA, it's a huge, crazy amount of numbers, right? And very common. So a brute force attack is literally trying every combination of every set of numbers to get the right one to break the key, right? So like if you had a key that only had four digits, A, B, C, D, you have to do every combination like A, B, A, B, right? But imagine that a string, right? So these researchers showed that theoretically a high-powered normal computer would take 300 trillion years, which is impossible, but again, theoretical, to try and brute force attack a 246-bit RSA key, whereas a quantum computer, which had like, let's say 100 qubits, right? So look that up maybe, could do it in about 8 hours, right? Or the other one that I've seen, the other paper that I've seen is that what would take every computer on the planet to break a 256-bit AES key would take, 3 or 4 days to brute force attack. Every computer combined, but every classical computer would take a 50 qubit or 100 qubit quantum computer 3 minutes to break, right? So why this is important to understand is because when this type of computing comes online, and people say, well, will we ever have quantum computers in our hands? And the answer is probably not. They'll be sitting off site somewhere, because by the time quantum computing comes online, you'll be up to 6G, 7G, 8G, right? So you won't actually need to have a chip in your computer. It'll just get it right. So we'll see. But the point is that all of this computing coming online makes what we've just done in the last 30 years literally look like a stone wheel and a stick, right? So, and if you're interested in how quantum computing works, it's a whole subject and it's really interesting. But do know when it comes to security that all current security in its current form will be compromised. And so all governments know this, right? A lot of industry knows this. And it's happening quickly. So sometimes people say, well, when is quantum computing coming online? And people say, well, it could happen anytime, 5 years, 10 years, we don't know. But you can right now go online and use a quantum computer. IBM does it, a couple other companies do it. And by the way, it does not work like traditional computing. It's not input output. It's a whole different thing, right? It's not based on digital information, ones and zeros. It's based on all information all the time and probability of certain blocks of information being correct. It's a whole subject. It's very interesting, and it will be the future of computing. There's no doubt. But when it comes specifically to security, it's important to understand that all current security can be broken, or most 98% can be broken with the use of quantum computing, right? So, okay, so quantum computing side. So this is interesting. There's a URL down here, which, check out the website, CVE details. So this is an interesting one. So this basically shows all known security vulnerabilities by product. And so I've just taken one little image here. But why this is important is because these are the companies themselves, or people that have gone to them and said, look, there's a security vulnerability. So they keep track of all the open security vulnerabilities. So a security vulnerability is a loophole or something that is a known bug in the code where people can somehow get entrance into other parts of the code, right? So this is very worrying. So obviously you can see Microsoft doesn't do very well, but that's not even the problem. The bigger problem is Debian and Google and anyone that's doing Unix-based systems. All the Unix-based vulnerabilities are more severe in my world than Windows, because the world's infrastructure and military and everything else works off of Unix, right? So even though it looks like, oh, Microsoft is not very great here, that's slightly irrelevant. But look at Apple. I mean, Apple's got 12,100. This is recent. Like, I literally just grabbed this like a couple of days ago. So this is not from years ago. This is like now. And if you go to that website, you can literally see every product, everything, all the security vulnerabilities, right? So that, it's just the way it is. When humans build things, code, there's going to naturally be errors in that code. Now, interestingly enough, I'm sure some of you have already kind of seen this happening. A lot of code now are starting to be built by AI. So it'll be interesting once we're not coding anymore to see how these vulnerabilities change, because an AI system could technically code, check for known vulnerabilities or unvulnerable, and then readjust the code, right? So that's happening too, right? AI. So that's interesting, right? This is a kind of interesting thing. So in the courses, one of the things that I say is, like, the biggest threat to security, not in a factory per se, but your own security is you. But in a factory, it may not be you, but it's your fellow employees, right? So it's important to understand that the more human involvement there is in security coding, setup, and access, the more error there is going to be, right? So I don't need to go through this whole slide, but the point is that most security is caused by human error, whether it's in code, whether it's left open ports, whether it's passwords written on a sticky, whatever it is, right? So why I'm saying this is because in the world that I'm trying to create and design, we're trying to take people out of it completely, like literally, like the less humans involved in security, the better. And I mean permanently. I mean, just put it in the network, don't have anyone manage it, have the AI manage it, right? So, because once you start putting people into the mix, you're going to get errors. And once you get errors, you get vulnerabilities, you get loopholes. So it's just important to know right now that the biggest cause of security breaches are people, not surprisingly, right? I'm not going to go too much because we're kind of going over time, but this is just to give you a glimpse of what a threat model looks like. So in businesses, when people say, okay, here's our infrastructure, what are our risks, right? Right. So it's called threat modeling. It's a whole like kind of known way to do it. Are there problems with it? Probably. I don't think like this really, because I think there's so many problems inherent, in case you haven't figured that out. I think there's so many problems inherent in current, the technical parts of cybersecurity that's all great. This is all great to like show to your board or whatever that, oh yeah, you're thinking about it. But the reality is that what we need in industry and other places is solutions, not models, right? We need solutions. So, but it's important to understand anyway, to understand that how people think about risk modeling. And if you take one of the classes, that there's more detail about this, right? I don't know how many more slides I have left. Hang on. Let's see here. I think that's kind of it. Oh, yeah, that's it. That's the last slide. So in the class, I think that there's two. There's kind of a basic cybersecurity one, and then there's a Industry 4.0. Although I'm talking with the DHI guys about maybe adding more and updating. But the kind of key takeaway from these presentations are, start thinking about the merger of the physical world with the digital world in the current paradigm of computing, which, as I've kind of pointed out in this presentation, is highly centralized, but we're moving away from that centralized model to decentralized. And that doesn't mean everything's going to be decentralized. There'll always be some need for centralization and all that. But, you can imagine like a really interesting thing is like a smart city, right? So one of the reasons smart cities haven't happened is because nobody can easily figure out how anything can talk to anything else that, are owned by different people in real time securely, right? I mean, just as simple as that, right? Everyone had visions of smart cities and all this stuff, and we're getting there, but there's been many problems, of which security is a massive one, right? Because think about, 2 or 3 different owners of different things in these smart cities, buses or, different, signs that have sensors or whatever, services. They're owned all by different people. They're running different operating systems. They're sending different packets. So how do all those things get to talk to each other securely without somebody sitting in the center? And even if there was somebody sitting in the center, who's going to manage all that, right? So you can see where the problems are and why truly smart cities haven't happened yet, but coming, right? I think. The second point is to understand that in the 21st century, data is the battleship, right? So everyone, as I just showed you on the first slide, where everyone's trying to access everything all the time, it's because everyone wants assets. And like I said, even if you don't think, or your company doesn't think that an asset may or may not be important, or may classify it on a certain level of importance, that may or may not be the case, because what you don't know, or what the company doesn't know, is how that information is going to be used, what it's going to be combined with, what other things have been taken into account around the data that's trying to be extracted from you or your organization, right? Since new data and groups will be made available on the outside of, all right. So this is an interesting one. So as automation comes on, how do people and organizations get incorporated into this, sometimes without their knowledge, right? So sometimes it's kind of like if there's a race going on and you were just to be dropped in the middle of the race, and nobody asked you to be dropped in the race, but then all of a sudden you're being pushed along by everyone else. So this is starting to happen in that, individuals and corporations, parts of data. So data that once is out and becomes part of this whole river of structure and analysis and all sorts of things, right? So it's a really interesting, that's more of a philosophical thing, like how does automation or getting automatedly incorporated into these systems, maybe sometimes without your will, how does that affect you from a security standpoint, right? And then lastly, something we all know, right? Like the kind of rate at which this is all changing is unprecedented in human history. And I mean, I think when quantum comes online, and I've seen many changes even in the last 5 years, right? Quantum comes online, AI, machine learning. I think that in the next 20 years, the planet will probably be unrecognizable, assuming we don't destroy it first. But from a technological standpoint, I think that we will make more progress in the next 20 years than we've made in the last 70 years, more. And in the last 70 years, we've made more progress than we made in the last 600 years, right? So yeah, so it's exciting time to be kind of in the field of robotics or AI or security or all of it. So that is about it. There's a lot to cover. I hope this was kind of a little kind of a peek into the world of cybersecurity, which is actually, like I said, sometimes people think it's quite boring, but it's not. Like if things aren't secure, then there are big problems, obviously. Yeah, I'm going to stop and let you guys ask any questions and give it back to Alex.
Thank you so much, Chris. It was great. So I'm first just gonna, they were asking about the courses, if these are free courses or paid. It's absolutely for free. These are free courses, open for all and free, so you don't have to worry about that. And Chris, we've got one for you. Sheila was asking, what type of certification do we require to get a cybersecurity job?
Yeah, so Yes. So there are various. Oops. Oh, there we go. Yeah. So it depends on what level you want to work in an organization. But so, for example, the program here at Oxford, there's a master's in software engineering and system security, and they have a special track that is approved by the NCSC, right, which is part of the GCHQ. So for those of you who don't know, the GCHQ is kind of like the British CIA, right? So what will happen in the security courses, they'll have certain tracks that say, NCSC security approved, but really for a security job, it depends. Like it depends on where you want to go in the organization. So, what people want is, in terms of, just basic, like, 6 months certification, I don't know the answer to that. But for higher level jobs, that people generally want masters or PhDs in kind of cybersecurity related things, plus years of experience doing it, right? But just to get started, as long as you've got kind of like network systems, IT, any of those kind of certificates, or not certificates, but knowledge, right? So, in your portfolio, right? So network management, any IT systems, and then having that like peppered with security, because there's a huge demand, right? It's actually a good question. I should probably look into it, but it just depends on what you want to do. Like, do you want to be an IT person? Do you want to be a manager? Do you want to be a leader in the organization, right? It kind of just depends on what you want to do. There's a lot of programs out there now where, you can do them kind of part-time while you're working. So I think, here at Oxford, and I think even some of the other schools in the US like MIT and Stanford, they all do it, right? So, and it's a huge area, right, to be involved in, right? There'll be plenty of jobs in cybersecurity for years and years to come. So if you want to get involved, I highly recommend it, right? Because you can tell by this presentation that I just gave you, things are changing quickly, right? So the landscape's changing quickly. Just because our use of technology as human beings is changing, right? And so the security has to change with it. So yeah, sorry, it's a bit of a long-winded. I don't know the exact certificates you would need, but I mean, obviously get a BA. If you don't have a BA in computer science, that'll help. But there are plenty of master's programs in cybersecurity or cybersecurity related, right? It's, as somebody who hires people, for me, it's less about certification and more about experience, right? Like, what have you done? What are you out doing, right? And so, the first step would be just to get in an environment where you're doing stuff, right? And that's more important than a certification in a way, right? I mean, it's great to have it on paper to say, oh yeah, well, I did this thing, but I mean, somebody who's managed a network in a factory, right, is more impressive than somebody that has taken a course on network management, right? You understand? So it's important to have kind of a combination of both, I think. It's not just about certifications. I mean, people who hire people in this field just don't look at certification. Right. Anything else?
We have another question, which is if we will be sending the presentation after the webinar. No, we won't be sharing the presentation per se, but we are recording the session and we will upload that in the YouTube channel of DIH². So, basically there you'll have access to the presentation somehow, but in the form of a recording. So I hope that helps, Niviana. If anybody else has questions, I've enabled you guys, if you want to like unmute yourself and just, say whatever you want, you're also able to. And I guess if not, we'll just wrap it up.
Yep. If anyone wants to see the presentation later and has a question, just send it to Alex and she'll get the question to me and I can answer. Yeah.
Yeah, absolutely.
All right. I hope it was helpful. And thank you guys very much for attending, getting up early. And thanks, Alex, for hosting. And I will talk to you.
Thank you so much, Chris. Thanks. So yeah, everyone, thank you for attending. And you just need to stay tuned to the Accelerator's different social channels. And if you want to course any of the MOOCs we have, you can go to this URL. And we have our next webinar. I'll just put the URL here, which is Introduction to Intralogistics. It's happening on the, when is it? The 22nd of March at 12 in the morning. So, you know, everybody's all obviously welcome to join us, to sign up. And thank you so much, Chris. That was super interesting. And, you know, we'll speak soon for more.
Yep, great, guys. I'm going to jump. Thank you, Alex. Bye.
Bye-bye. Thanks. Thank you, everybody. See you next time.